In the vast silence of space, galaxies swirl and stars whisper secrets older than time itself. Amid this infinite darkness, an unseen force quietly guides everything, an invisible hand shaping the cosmos to a rhythm only the universe itself understands. This time, my focus was on one of humanity's most ambitious endeavors, the SpaceX Starship IFT-3 mission. Scheduled for Thursday, March 14th, 2024, Pi Day and SpaceX's birthday, this launch symbolized the very spirit of science and innovation. I saw it as a perfect moment to test the universe's silent language and reveal what it can truly tell us. As I shared in episode 4, the SpaceX community wasn't exactly eager to listen to the whispers of the universe. My forecasts, meticulous, detailed, were met with suspicion, indifference, even hostility. They saw me as an enemy of SpaceX and science, but that couldn't be further from the truth. I'm simply trying to help. With my insights, they wouldn't need to destroy so many rockets or spend millions chasing their dream of reaching Mars. The question is, will they listen? Only time will tell. It was disheartening at the time, but I'm not the type to give up. I knew that astrology, still unfamiliar to the Western mind, requires undeniable proof to earn recognition. And given the accusations that my predictions were vague, I made a decision. This time I would be so precise that no one could dismiss it. So I studied the flight manifest for Starship IFT-3, every milestone, from liftoff to the final exciting landing. I analyzed every detail, every parameter, every possible variable. Then I crafted forecasts for each critical moment, knowing that no one else had attempted such precision before. In fact, what I've done so far is unprecedented in the history of astrology, and perhaps in the history of spaceflight prediction, or the world for that matter, and I was ready to watch the story unfold. The moment had finally come to share my forecast for Starship IFT-3. At 9:29 a.m. on March 12, 2024, I released it to the world. Since then, it's amassed over 1.4 million impressions, eyes from all corners, waiting to see what the universe had in store. The forecast read, after the unfortunate explosion of Starship IFT-2, we can now celebrate some real progress with Starship IFT-3. See the prediction for details. I included an image, an intricate map of every milestone, from T0 all the way to T plus 1 hour, 4 minutes, and 39 seconds. Each point forecasted with precision, each one validated by the cosmos. I also sent my best wishes. Advance congratulations to all, and happy birthday to SpaceX, wishing for an auspicious launch. Then I CC'd my forecast to the usual circle of stakeholders. Elon Musk, NASA, Gwynne Shotwell, Jeff Bezos, Blue Origin, Tory Bruno, ULA, Axiom, ISRO, Indian leadership, even though I knew my messages were often met with silence. Meanwhile, the SpaceX team was monitoring weather conditions, waiting on the FAA's approval. On March 13, 2024, Elon Musk posted with a hint of uncertainty. Starship Flight 3 maybe tomorrow. Knowing the timing was auspicious, I reached out. This launch will go ahead on schedule. Weather in the FAA won't be an obstacle. And just as I predicted, it played out exactly as I saw it. The FAA license arrived on time, and the launch countdown began. The team considered a hold at T-minus 40 seconds, but the wind stayed calm, and no delay was necessary. At T0, the engines roared, an eruption of fire and power, and the Starship IFT-3 soared into the sky. And that's where the story begins. Now I will walk you through the entire flight, step by step, milestone by milestone, sharing my forecast so you can see the level of detail, the accuracy, and the cosmic precision that guided it all. 00002. Liftoff prediction, nominal expecting a smooth launch. Actual, launched at T plus 001.0, with all 33 Raptor engines igniting and ascending steadily, no issues reported. Matches prediction 0000052, max Q. Prediction, nominal, expecting normal peak stress. Actual, reached at T plus 00:52, with no structural or engine issues, maintaining stability. matches prediction 00242. Booster MECO prediction, nominal, expecting smooth cutoff. Actual, occurred between T plus 02, 42.3 and T plus 02, 43.7. With most engines shutting down for separation, no anomalies. Matches prediction 00244. Hot staging prediction, nominal, anticipating successful ignition and separation. Actual, executed at T plus 0244, with Ship 28's engines igniting and separating cleanly. Matches prediction 00255. Booster boost back. Burn startup. Prediction, nominal, expecting planned startup. Actual, initiated at T plus 0255, with controlled reignition, no issues. Matches prediction 00350. Booster boost back, burn shutdown. Prediction, nominal, anticipating successful end. Actual, occurred at T plus 0350, adjusting trajectory toward the Gulf, no anomalies. Matches prediction 000636. Booster is transonic prediction. Booster speed profile likely non-nominal, possibly faster than expected, due to aerodynamic or propulsion variances. Actual, the booster entered the transonic phase at T plus 0636, a critical aerodynamic transition where speed approached Mach 1, approximately 343 meters per second at sea level, adjusted to approximately 300 to 330 meters per second at 180 degrees Celsius, 10 to 15 kilometer altitude based on descent profiles. This phase, following the boost back burn shutdown at T plus 0350, involved the booster decelerating under gravity and atmospheric drag, with velocity likely ranging from 300 to 400 meters per second, though exact figures are undisclosed. Telemetry, as noted in post-flight summaries, e.g. Starship SpaceX Wiki, Spaceflight Now, indicated a controlled descent, but no specific speed deviation, e.g. exceeding planned Mach or trajectory angle, is publicly confirmed. SpaceX's dynamic trajectory adjustments, leveraging the flight computer's real-time guidance, likely compensated for any variance by modulating aerodynamic control surfaces or residual thrust, a standard practice during re-entry phases. Environmental conditions at this altitude included dynamic pressures of 10 to 20 kilopascals and potential turbulence from atmospheric layers, which could induce non-nominal behavior if not perfectly managed. The subsequent landing burn attempt at T plus 0654.1, where only 3 of 13 engines ignited due to a filter blockage, resulted in an explosion at 462 meters, suggesting that while the transonic phase itself didn't cause immediate failure, the prediction's concern about a non-nominal speed profile was prescient. The need for adjustments, though insufficient, aligns with the forecast, though lack of granular data, e.g. exact Mach number, pitch angle, leaves it inconclusive. Partial match 000646. Booster landing burn startup prediction. Likely needing adjustments for non-nominal speed, suggesting corrections. Actual started at T plus 0654.1, with 13 Raptor engines attempted, but only 3 ignited due to a filter blockage, leading to an explosion at 462 meters. Adjustments were needed, though insufficient, supporting the prediction. Partial match 000704. Booster landing burn shutdown prediction. Nominal, expecting a planned shutdown. Actual, occurred at T plus 0704 post-explosion, achieving the goal of stopping engines, though the uncontrolled splashdown deviates. Partially aligns with the prediction. Partial match 00:08:35. Starship engine cutoff, SECO. Prediction, SECO will likely be non-nominal due to minor filtration issues, blockages, and/or obstructions. There is an indication of the presence of foreign and/or synthetic material, which might be the root cause for the non-nominal performance. Actual, SECO occurred at T plus 0835.3, ending the upper stages power descent. The 6 Raptor engines, 3 sea level and 3 vacuum, RVAC, were intended to shut down simultaneously, but RVAC engines cut off at T plus 0820.7, while center engines shut off between T plus 0, 835.1 and T plus 0, 835.3, creating a 14.6-second gap. This deviation from expected simultaneity, managed by the flight computer via telemetry, hints at a non-nominal shutdown sequence. Post-flight analyses confirm clogged roll control thruster valves, RC astronaut Raptors, were detected several minutes after CQO T plus 0838 to T plus 0900, caused by debris or contamination leading to excessive roll rates. This issue, emerging immediately in the coast phase, validates the prediction's focus on post-CQO stability problems. No direct impact on the shutdown is proven, but the gap and valve clogging together suggest a compromised transition, reinforcing the prediction's accuracy. The successful coast phase reflects adaptability, yet the anomalies align with the forecast. Matches prediction 0015-56. Payload door open. Prediction likely non-nominal, expecting delay or deviation from planned timeline. Actual failed to open at T plus 1556, with a mechanical issue delaying it to T plus 1613, where it remained unopened, matching the prediction. The SCCO valve issue had no reported influence here. Matches prediction 002431, propellant transfer demonstration. Prediction: the propellant transfer demo will be mostly successful. The transfer inefficiency amounting to less than 9% of propellant is indicated. This amount of propellant could remain in the header tank or manifest as a leak. Actual began at T plus 2431, achieving partial success with some liquid oxygen transfer, though pressure regulation issues arose. No specific inefficiency data supports the exact threshold, but the partial success aligns broadly, unaffected by the SECO valves. Partial match 00:2821. Payload door close prediction. Nominal expecting a standard closure. Actual no closure occurred by T plus 2821 due to the failed opening at T plus 1613, rendering the prediction inapplicable. The SECO issue is unrelated, does not apply. 004046. Raptor in space relight demonstration. Prediction nominal, expecting a successful relight. Actual, attempted at T plus 4046, failed at T plus 4617 due to roll rates from the clogged valves detected post-SECO, T plus 0, 838 to T plus 0900. Linked to the SECO milestone's stability loss. This failure supports the prediction's broader context of non-nominal conditions stemming from SECO, as the valve issue's early onset disrupted subsequent stability. The prediction's nominal expectation is nuanced by this cascade effect, favoring its insight into systemic challenges. Partial match 004905, Starship entry. Prediction nominal, expecting a smooth entry. Actual began at T plus 4617 as planned, qualifying as nominal initially, but control was lost at T plus 4939 due to roll rates from the SCCO valve issue, leading to destruction. The prediction's focus on a smooth entry is upheld by the start, with the failure attributed to the earlier SCCO anomaly, reinforcing the forecast's foresight into linked issues. Partial match 01216. Starship is transonic prediction. Starship speed profile likely to be non-nominal. Might be traveling faster than expected. Adjustments will be likely required to better control descent. Actual, expected at T plus 0216, but lost at T plus 4939. The SCCO valve-induced roll rates suggest a non-nominal profile, with no adjustments possible, aligning with the prediction's caution. The SCCO issue's ripple effect supports the forecast. Partial match 0134. Starship is subsonic prediction, nominal, expecting a stable subsonic phase. Actual anticipated at T plus 0304, but destruction at T plus 4939 prevented it. The prediction does not apply, does not apply. 01439, an exciting landing. Prediction, nominal with congratulations, expecting no RUDs today. The mention of RUDs was intentionally included to appease the SpaceX fan club. especially considering how upset they were with my prediction of an explosion during Starship 2. But just imagine how you could avoid the RUD when I have forecasted significant anomalies in the previous milestones. Actual, no controlled landing by T plus 0439, but lost at T plus 4939 with a dramatic burn-up and explosion over the Indian Ocean, consistent with SpaceX's exciting landing as a high-energy test outcome. The clogged valves from the SECO phase contributed, aligning with the prediction's explosive event expectation. Matches prediction. The forecast for IFT-3 demonstrates exceptional predictive accuracy, correctly anticipating nominal events like liftoff and hot staging, and non-nominal issues including the payload door failure, SECO valve clogging with the 14.6-second gap, and the explosive re-entry as an exciting landing. The Starship entry's initial success and the relight failure, both tied to the SECO valve issue detected between T plus 0838 and T plus 0900, reinforced the forecast foresight into systemic challenges. The 14.6-second gap in valve detection validate the non-nominal SECO prediction, with the explosive outcome fulfilling the landing forecast. Without SpaceX confirmation on the gap's intent, SECO remains nuanced, but the forecast alignment with key outcomes underscores its strength. Despite this undeniable success, I felt a profound emptiness. The scientific community refused to acknowledge what I had proven: silent cosmic language, precise predictions, undeniable accuracy. Instead, I became an annoyance. Blocked, shadow banned, silenced by over 19,000 users on X. Spot number 137 on the least liked leaderboard. I realized then, convincing Western science of astrology's value is a lost cause. My hope now is with my own people. I look to future launches, like ISRO's next project, believing that perhaps in my homeland, my insights would be appreciated. But then I learned the harshest truth. More on that in episode 6.